So you guys have that sheet in front of you. I would just start kind of copying down as I talk through this. Right? You have family if we have these new vocab words. So family of functions and parent functions. So starting with family of functions, we're talking about a group of functions that have characteristics in common. Right? So this is some broad group. So we have seen this so far this year, and linear functions is what we've seen so far. So linear functions, this is an example of it. Linear functions, those are the graphs what we were just graphing, like the y equals 2, x equals 1. Those are examples of linear functions. So think about, if that's a family of functions, what common characteristics do they have? Think about all the lines we've graphed in chapter 5. What things do all of those graphs have in common with each other? JJ, give us one.
They're all straight lines.
They're all straight lines. That's something they have in common. Okay, what else do they have in common? Press. They all have an x and y. G. They have a constant rate of change, right? We've been calling that slope. Yep. And, that really is it, but you could add other stuff.
They go on forever.
They go on forever, right? They continue infinitely. And a lot of the times we think of they all have a y-intercept, right? Because they cross the y-axis. So that's an example that we've seen. We didn't use this vocab, but it is what we already saw. So then the next thing is we have a parent function. So it's the most basic function in a family of functions. So if we go back to linear, what do you guys think the most basic linear function is? Well, I don't know if we actually ever graphed it, but it doesn't mean you couldn't come up with it. What do you guys think the most basic linear function is? Take a guess. We need a y in there somewhere. There you go. Y equals x is the most basic linear function. Slope of 1, y-intercept of 0. That's as basic as it gets. Everything else is what we call a transformation of that. So we're going to be talking about transformations today, but we're going to do it with absolute values. So transformations, we've got a few things to note. One of them is what's called a translation. Now, if you forget this vocab, that's okay. Hopefully you don't forget what it means, though. So translation, this is a vertical or horizontal shift. Meaning the graph is either going to move up and down, like changing your y-intercept, or move left and right. So we're going to take an absolute value graph, we're going to move it up and down, we're going to move it left and right. We are also going to have a reflection. And so a reflection is exactly what it sounds like. This is just a mirror image. Across some line. So it's essentially you just take one graph and you flip it over, right? That's what a mirror image would be. Flip it one way or the other, up and down, left or right. You're just reflecting it. And then the last thing we're going to look at is what we are going to call a vertical stretch or shrink. Now I gave you guys a big gap on that at the beginning there because we're actually going to end up taking a couple more notes underneath this that fit this transformation topic. But before we do that, we have to do some other things. So hopefully you still have a big gap there. We're going to add a couple notes later on. But now what I want you guys to do, off to the right side, there's that first graph. I can't remember if I labeled it parent function or not, but that is your parent function. So we're looking at f of x equals the absolute value of x. Right? If I don't think I labeled it parent function. Did I? All right, perfect. So it's already there. That's our parent function. Now, we've never graphed this before. So when you haven't graphed something before, what we do is we create a table of values. So let's do that. Maybe off to the right side there, create a table of values. And let's just pick easy ones to deal with. So I like -2 for x, -1, 0, 1, and 2. And we're going to be graphing this one together. So we have our table of values, and we want to come up with a pattern. What does this graph look like? So everybody, when you plug in -2 to an absolute value, we get out 2. It makes negative positive because it's distance from 0. Okay, you plug in a -1, you get out
1.
0.
0.
1. 2. There we go. So let's plot these. So we have, these are all x comma y coordinate points, right? So you guys already have that, the grid in front of you. So let's go left 2, up 2. That's our first point. Let's go left 1, up 1. That's our second point. 0, 0, 1, 1, and 2, 2. So we have what is starting to look like a V-shaped graph, and that's what it is. So let's connect those dots, try to make a nice straight line. So already we are seeing a characteristic of absolute value functions. All absolute values are V-shaped graph. So all absolute values are V-shaped. So if you're graphing this and you don't come up with a V-shaped graph, something went wrong. This is a basic characteristic of absolute value graphs, right? Every one more or less looks like a V, right? Some of them are going to be skinny, some of them are going to be wide, but they more or less look like a V. Okay? Now a couple things we want to note here, and this is going to help us, and these are other characteristics, things that they all have. So what every absolute value graph has is called a vertex. It's where the graph turns. So the graph is always, because it's a V shape, it's always going to have a turn, and we're going to call that turn a vertex. And then one other thing that they're all going to have in common is they have what are called in geometry terms a ray, because you have a point, so it has an endpoint, but it only has one endpoint, the other side goes infinitely. But what you have is each side of the graph is going to have a slope, and this parent function has a right side slope, and if you go up 1, right 1, so it has a right side slope equal to 1. Now the slopes are going to change for each graph, but they all have a right side slope and a left side slope. And the left side slope, we go down 1, right 1, which means we have a left slope equal to -1. So the sides of the graph, they're always going to be just opposite of each other. One side will be a positive, the other will just be the negative of that number. All right? You guys just graphed, in general, you graphed the absolute value of x and then you added some number, right? So somebody raise their hand and tell us what happens when you add or subtract a number to an absolute value. Looking at those graphs, Luke, what's happening?
The one you add is like the y-intercept.
Okay.
Like
so visually, what's going on with your graph? Your parent function, what's happening to that first graph? It's
like exactly on the x-intercept, like where the x crosses the y.
okay, but like visually, what's going on, Monica?
It's moving up and down.
It's moving, right? It's just going up and down because the intercepts are changing, right? So visually, it's moving up and down. So here's what we're going to say, and so this is where we're going to start switching back between your iPads and your notes, right? We're going to go back and forth. So make sure under transformations have this written down. This is the general of what you guys just did. When you add, and k is just some number, right? It's any number you want it to be, positive or negative. What does this do? This is called a vertical shift. You remove, this moves, or shifts. Let's use the word shifts. Shifts the graph up or down, right? So plus k means you go up k units. And all it is, it's just your parent function, right? So nothing changed other than that vertex point. The vertex just moved up k units. Or minus k means go down k units. Right? That's all that happened. So then now on your iPads, you can get rid of those graphs, but keep the parent function on there. You guys are going to end up doing absolute value of x minus h.
Moving left and right.
Okay, so we'll say that. So the first one was a vertical shift, right? The second one is a horizontal shift, so we are going to shift left and right. So let's be specific. So when does it shift left? When does the graph shift right? So we're going to write in x minus h and x plus h. So which of these two, when am I going to say shift right and shift left?
So it's a negative h, it shifts, right, or no, it shifts, yeah, it shifts right. and
Okay.
positive.
So this is going to be, we're going to go right, however many, whatever that number is, so go right h units. This is opposite what you think it's going to be, right? You would think a minus h would go left, but it goes right, and a plus h goes left h units. And if you're unsure, play around with that graph, right? Keep putting in different numbers and watch that vertex move side to side. All right. So what are you guys noticing? What happens if we do both the vertical shift and the horizontal shift? We kind of put them together. It moves it diagonally, right? It's going all over the place. So here's what we're going to say. When you get a graph that, you get an equation that looks like this, think about your vertex, right? Because that's going to be the most important point for an absolute value graph. This is going to go ahead and this moves your vertex. So now your vertex is at the point h, comma k. And if you're unsure, look at your graphs. Look at what's being added on the outside. That's the y value. One sec here. What's on the outside is your y value. Come on. And what's being added on the inside is your x value. We're going to do this first one together. So here's your equation. I'm going to give you f of x equals the absolute value of x minus 1 plus 2. So for all of these problems, whenever you're graphing these, and we'll get to graphing in a second, the vertex is always at the point h, comma k. H is the number on the inside, k is the number on the outside. So in this case, and remember the x's are opposite what you think. So our answer to part A is going to be 1, comma 2. X's are on the inside, y's are on the outside. So this is what we call a vertical and horizontal shift, or translation. This is the parent function, and it was picked up, it moved up 2 and right 1, and then put back down. It's the exact same graph as your parent function, but it went up 2, right 1, and then it's the exact same thing. Yeah.
Wait, so would it be negative one or positive?
Positive because it's opposite what you think, right? So you were telling us that when it's x minus h, we go right. So to the right side is positive x values, and x plus h is to the left. So those are the negative x values. So you're right. It's tricky. It's going to throw us off at first. This is supposed to be a positive value. All right, I'm going to put a bunch up here. We need to be comfortable with finding where is this vertex going. Is this shifting all around? So our next one, f of x equals the absolute value of x minus 5 minus 1. Part C, f of x equals the absolute value of x plus 2 minus 7. And part D here, f of x equals 2 times the absolute value of x plus 1 plus 2. So let's go over these. Let's get some vertices on the board, right? The plural of vertex. So it's always at h, comma k. So volunteer for part B. What's the x, comma y? Where did our vertex go to? Sam?
To 5 and -1.
There you go. So this is there's your h, there's your k. The inside, it's opposite what we think. So a negative 5 shows up, so our x value goes right 5 and then down 1. Right? That's the shift of this graph. Your parent function went right 5, down 1. Somebody else, part C here. Where's the vertex now? It was at 0, 0, and then it became. Someone raised their hand.
To -7.
So -7 for the y. Opposite what you think on the inside.
-2.
-2. X values are opposite. So this graph, it went left 2, down 7. Same graph as before, left 2, down 7. Alejandro, you got the next one?
Mm-hmm. It's -1, 2.
Negative 1, 2. This graph went left 2, left 1, up 2. Notice that even if you have a number in front, that doesn't matter, right? That doesn't change your vertex. The vertex is always H, comma K. Always. All right? Hayden, what's going on?
A changes the angle of which the rays come out of the vertex.
All right, good. So it changes what's going on there. So this is going to be a stretch or a shrink. It's going to make the graph, so A makes the graph skinny and wide, right? So an A greater than 1 makes the graph skinny. And an A that's between 0 and 1 makes the graph wide. Okay, what else does A do? So that I just phrased what Hayden said in a different way. Same thing. What else does A do? Or what do you notice about it? Messing around, going back and forth on that slider. Jaden?
When you're at 0, it's flat, and then above 0, it's like, I don't know how to explain it.
Okay, yep. What else? What happens when it's below 0?
Weird.
You call that, Alejandro?
If it's below 0, it'll go under the line, and since at 1, it's exactly the same. The opposite one is -1, and that'll make things up here.
All right, so negative A, this is going to be a reflection. It flips the graph. It flips your graph. All right, so then here's going to be kind of a nice trick for when you're graphing. A is the right side slope. So you know how we counted rise over run? Whatever number A is, if it's -1, you would count down 1, right 1. If it's +3 over 2, you'd count up 3, right 2. If it was -3 over 2, you'd go down 3, right 2. A is always the right side slope, and so then that would mean the opposite of A is your left slope. This is a lot of information, right? Here's the key though. If you know the parent function, that's going to be the key, is knowing what the parent function is and what it looks like, because then everything else is just based on that one graph. So you have to know the parent function, have to know it. The other graphs are all based on that one. All right? So let's take this idea, and then we're going to go back. We're going to go to the back side of your papers now and finish up. We're going to do some graphs. So we're going to go over these together, okay? But all we need to do is find the vertex and then count the slope, right? So we shouldn't have to plug in any points. So let's go to that second example. This first one, we're going to do it together. Well, actually, we're going to do all of them together. So we're going to go f of x equals, let's go with absolute value of x -1 plus 1. So the very first thing we need to do is find the vertex. That's the number one thing we do, find the vertex. So vertex is always at h comma k. Someone raise their hand and tell us, I'm going to plot this. Sam, where am I going to plot the vertex?
1, 1.
1, 1. So you guys should do the same on your paper. Plot 1, 1. And then we're looking at the A value. So somebody tell us what is, or everyone should be able to tell us, what's the A value, the number in front?
You're 1.
What's the number in front? What's this number? It's not written, so it has to be a
1.
1. It's the number 1 if it's not written. So that's your right side slope. So then you just count up 1, right 1. And then our left side slope is just the negative of that. So if the right's 1, the left is -1. There's your graph. We didn't have to plug in any points. Right? We don't need to know much else. We know that it has a vertex at h comma k. Your graph is a V-shaped graph. So let's say we changed it. We did this. So your next one, this would be A, part B, f of x is 1 over 2, absolute value of x plus 2. So first thing we do, we find the vertex. It's the very first thing we always do. It's always at h comma k. So somebody tell the class. Raise your hand. Bill?
0, -2.
In that order?
Oh,
-2, 0. There's no k value, so that's the y. So we're going to go left 2. That's our vertex. And then count our slope. So everybody, what's our slope, our right slope in this problem?
Up 1 over 2.
There you go. That's the right side. So up 1 over 2. Up 1 over 2. The left is simply the negative of that. So you're going to go up 1, left 2. That's your graph. You didn't have to plug in any points. You didn't have to do anything else. You find your vertex. You count your slope. That's it. Let's do 2 more. And these are quick problems. Let's see. All right. The next one. Let's go with f of x is negative absolute value of x minus 2. So let's, once again, start with our vertex. Somebody else that hasn't told us where a vertex is. Ted, where is the vertex?
-1, negative.
So the h is always whatever number's on the inside. Is there anything in there? Are we adding anything to x?
No.
Whatever you add to x. So we're adding nothing to x. So the x value has to be a 0.
Alright.
Then what's the y value?
-2.
There you go. 0 for x, -2 for y. So we're going to go left or right 0, down 2. The negative tells us it's a reflection, and that's the right slope. So we go down 1, right 1. That's the right side slope. And you just do the opposite. So positive 1, down 1, left 1. Graphing absolute values isn't as easy, but it's almost as easy as graphing slope-intercept form, right? Because you just have to plot a couple points and you're good. Okay? And actually, I want you guys to at least be able to start this assignment. So you got 5 minutes.